Good afternoon, everyone. My name is Brandon Carter. I'm an application engineer with Ally PLM Solutions. I want to welcome you to the Ally PLM Lunch Bytes series. For those of you not familiar with Lunch Bytes, what we do in Lunch Bytes, it's a series designed to give you an introduction to some capabilities within NX that are maybe overlooked. Future sessions will be delivered once a month, usually the second Thursday of each month at 12:30 Eastern, 11:30 Central. Yes, we're doing it the first week here in September of this month. Please check our website for upcoming Lunch Bytes topics. We want our Lunch Bytes to be valuable to you, so please let us hear any suggestions you might have for future sessions. Also, if you have any questions regarding today's session, please write them down and send them in an email, and I'll address those after the session. There's a few of you on the line with us today, so you'll be in listen-only mode. A couple of months ago, my fellow application engineer here at Ally did a presentation on sheet metal. Paul did that presentation. Today we're going to take a look at how to create flat patterns of sheet metal parts. And here in a minute I'll show you how to get to a replay of that sheet metal presentation that Paul did a couple months ago. So let's go ahead and get started. Excuse me, I'm getting over a cold, so I apologize for any coughs. So the agenda for today's session, we have about 30 minutes, and we're going to first of all look at preferences for NX sheet metal. We're going to take a look at using the unbend and rebend command. Then we're going to do a quick comparison of what the flat solid and the flat pattern command does for us in NX sheet metal. Then obviously it's important for us to make these parts, so we're going to look at how to export the flat pattern. We're going to look at how to throw the flat pattern on the drawing very quickly. And then just to make sure, if you're kind of new to the sheet metal realm, we'll look at how that flat pattern is calculated. And then just towards the end, I want to show you a quick example of a lofted transition. And also I want to introduce you to a tool called Step Formability inside of NX. So as I mentioned, we've done a sheet metal Lunch Bytes presentation a couple months ago. For the replay, visit our website and click on the NX Lunch Bytes video gallery. Also, you can visit a link on our YouTube channel, and the bottom link there is actually a direct link to the video on sheet metal that Paul did a couple months ago. So just to give you an overview of sheet metal, that would be the replay you would want to watch. The first thing we're going to discuss are sheet metal preferences. There's several things I want to show you today, so I'm not going to spend a ton of time on these preferences. But when we look underneath preferences in NX sheet metal, this is where we're going to define our part properties, what our material thickness is, what our default bend radius is for the part, our default relief depth and width. Also, this is where the parameters are going to be pulled for how the bend allowance is created, therefore creating our flat pattern. One of the things you'll notice at the top of the screenshot is you have value entry, which allows me to add these global parameters right here inside of preferences. You also have an option to select material and tool ID. And as I mentioned those, you'll notice at the bottom there is a text file that those can be customized, adding more materials or adding your own tools to that particular text file, so that it'll come up in this preferences dialog, and the location of that is in the default installation directory. In my case, I loaded my software to the default C drive, so you see I have program file, Siemens, NX8, the UGII folder, and also materials folder in there. The text file is called sheet metal material table.txt. Excuse me. I'm going to show you some of that inside the product here in a minute. The next tab is flat pattern treatments. So you'll see that you have corner treatment options that you can apply to your flat pattern. You have outside corner. If I hit that drop down in none, you'll see that I can add a chamfer or a radius. Notice the little image to the right of where it says none. It's applying to those vertical edges to break those corners. We can also do inside corner treatments with a chamfer or a radius as well. And like I said, I'm going to go through and bring this up in the software, so I'm going through these screenshots a little fast here. For my flat pattern display, just like it sounds, do I want the bend end up center line or the bend down center line or bend tangencies to be shown in my flat pattern? What colors do I want those to be, what line types, and so forth. Also notice at the bottom there are some default callouts, calling out information on my flat pattern, like what's the bend radius for this particular bend, what's the bend angle, bend direction, and so forth. So we're going to take a little more look at that as we continue throughout the rest of the session. And there's also some options here on the final tab, sheet metal validation. I can have a minimum tool clearance to make sure that maybe a deformation feature like a louver or a dimple is not going to be too close to a bend. And the values that are specified here, if you use the checkmate application inside of NX, you can run checkmate and have these parameters checked against on your model. The second option there is minimum web length, which would be kind of the length of a flange face. Maybe I don't want the length of my flanges to be less than, in this case, 0.5. So when I run checkmate against those, that will give me feedback that that is not in those validation parameters or design requirements. So let's go ahead and jump over into NX. Like I said, I know I went through those rather quickly, but I want to spend a little more time with those options now. I'm just going to start a brand new NX sheet metal template, and we're looking at the preferences here underneath preferences, NX sheet metal. So the first tab we saw on the slide was part properties. I do a value entry. Notice if I select the material selection, I can say select material, and that text file that I'm reading from, that sheet metal material text file I pointed out on the slide, you see that we have 7 materials defined. Obviously you want to go in and customize this to your needs, and notice how it populates that information for my material properties for my sheet metal file. If I cancel that, we can also do a tool ID selection. If I select tool, once again, it's going to go prompt that text file. I grab a particular tool. Notice I have thickness min, thickness max, bend radius, neutral factor. For this particular example, I'm going to stick with value entry, and maybe I'm going to change my material thickness to 50 thousandths. And what we'll do is later when we look at the flat pattern calculation, we'll look at this information for our material thickness. And also notice our bend definition method. This is what our neutral factor, or also known as your K factor, for your bend allowance. You'll see that here I have a neutral factor specified, which you'll see later when we talk about the calculation. I also have a bend table, which can be extracted from that text file. And also, if there's a formula specific to your needs, I can add a bend allowance formula right here inside the preferences. This is kind of the default type formula, and I'm going to use the neutral factor to calculate that flat pattern, or that bend allowance is what I should say. And like I said, we'll address that just a little bit later. If I go on to the flat pattern treatments, I discussed earlier how we can apply outside and inside corner treatments. You see I can add a chamfer or a radius to a certain value kind of globally to my flat pattern. My flat pattern simplify, I can simplify B-spline curves. I can remove system generated bend reliefs. And the bottom option there, I can maintain circular shape for holes in flat patterns. Think about a hole defined in a flat, as I format, or even opposite, as I flatten a hole, maybe on a circular part or rolled part, that hole shape actually turns into more of an ellipse. So if I want to maintain that circular shape for hole, I can have that option checked. Here's my flat pattern display. What do I want to display as far as curves on my flat pattern? I want the bend tangencies, which is where the start and finish of the bend occur. I want those to be displayed. Also, like I mentioned, here are the new callouts that I can have that information extracted for my flat pattern automatically. And you'll see that in action a little bit more in a minute. And the final was that sheet metal validation for your checkmate tools. So I've changed my material thickness to 50 thousandths, my bend radius to 50 thousandths. Let's go ahead and accept those changes. And I'm just going to go out here and create a part here quickly, just a tab with a couple of flanges. I'm just creating a rectangle, and I'm using the auto dimensioning, continuous auto dimensioning tools here to drive my shape. Maybe I want that to be 4 inches tall. We'll make that 6 inches long and keep it on center. We'll go ahead and drive these two auto dimensions. So there's a shape for our tab. Notice when we create that tab, it's pulling that thickness from my NX preferences. So there I've created my tab. Quickly here, I'm going to pull off a couple of flanges just by grabbing an edge. I want this to be 2 inches. I'm measuring from the web, which means from the bottom of the bend to the end of the flange. That will be 2 inches. And let's go ahead and do the same thing on the other side to finish that part. Okay, so just to get us started, remember we've changed the thickness to 50 thousandths and the bend radius to 50 thousandths. So the reason why we pointed out those parameters, those preferences, is because that's what's going to define not only the thickness and the bend radius of your formed part, but also the neutral factor, etc., of how we create the flat pattern. Now, before we get into truly calculating the flat pattern or maybe the flat solid even, how many times do you ask yourself, what do I do whenever I need to add a modeling feature in the flattened state? Maybe I need to locate a slot that's going to wrap around the bend. Maybe I have a rolled part that I want to put a series of holes in the flat and then roll that. So in this case, I would use tools called unbend and rebend. So let's take a look at a couple examples of that. So maybe I want to wrap a slot, and I want to locate that slot in a flattened condition. So because I want to do it as a modeling step, I'm going to use a tool called unbend. So I'm going to grab a face to be stationary and a bend to become flattened. So notice how I just flattened that one bend. Now what I'm going to do is add that slot in the flattened state. So I'm just going to apply a cutout, just do a little slot shape here. Notice the feedback I'm getting with my cursor. Just holding down the left mouse button to drag into an arc. Got my auto dimensions here. Let me get out of my profile tool. So I'll go ahead and drive some of this shape. Let's see, we'll make that 1 inch from the bend and somewhere 2 inches off that side. So basically we're creating this slot in a kind of a flattened state using the unbend command. Now I want to put it back in the form state, so I'm going to go ahead and rebend that bend that we flattened earlier, and now you notice how we applied the cutout in a flattened state and then we formed the model back. So this allows us to kind of get outside the box and apply some of those features in a flattened state. Typically, if you're doing something like this for every unbend, you're going to have a rebend, right? Because I have an unbend, I created the cutout in the flattened state, and then I formed the model back up. So keep that in mind. Maybe take this a step farther. Let's just create a new part here. Another example. And I'm going to grab a contour flange. Maybe we're going to create some kind of rolled part where it's a continuous bend. I'm going to grab an arc by center. For this to flatten, I need to leave some kind of gap here in the top, so I'm going to build a couple of construction lines to locate that gap. And like I said, I want to make those construction because or reference. I don't want those to be part of my profile. So let's just apply some dimensions to locate that. We don't want those to be quite vertical, so I'll put it a little bit on each side of 90 degrees, which is keeping my gap. Yes, I have a rather large gap. I'm kind of exaggerating that gap, and obviously it depends on what you need. But now that's an open profile, so that allows me to create that contour flange. So that's a continuous rolled part, one bend. So if I want to lay out a whole, maybe even a whole pattern in a flattened state, I can come up and grab my unbend, say what edge do I want to hold stationary, what bend do I want to flatten. Notice how it's now in a flattened state. I'm just going to come up here quickly and throw in a hole. And that's just at a point. I'm going to locate that point using my auto dimensions. And let's see what we got here. 1/2 inch hole through next, that's fine. And now I want to go ahead and place the pattern. So here, I'm going to locate my work coordinate system to define my pattern. I'm just grabbing each of these axes to kind of determine that. And now let's go ahead and add the associative copy, the instance feature, or the rectangular array basically. I'm going to grab that hole. Maybe I want 10 occurrences. Equally spaced, let's see, equally spaced out through there with my offset, and I want 2 occurrences with 2 inches in the Y direction. So notice we've created our pattern. Go ahead and apply that. There's our pattern in our flattened state. Now to get back to the form state, we're going to go ahead and do a rebend operation on that bend and form it back up. So notice how we've applied the hole in the pattern in a flattened state. Once again, we had an unbend in a rebend for that particular model. Alright, so that was unbend, rebend, like I said, as a modeling feature, not necessarily that manufacturing flat pattern that we need to spit out to DXF, but to use it for modeling type operations to lay certain features out in flat. So if you've used NX sheet metal, you've probably noticed there's a flat solid and a flat pattern. Flat solid is going to give us another separate solid body in the file in a flattened state. Flat pattern is what we're going to create to export maybe to a DXF for manufacturing, or also maybe to place on a 2D drawing. With that being said, you'll also notice there's a newer tool here called Export Flat Pattern, which is basically a two-click method to grab that flat pattern in NX and push it straight out to DXF. Also, it has a layer structure with that, which you'll see. Alright, so here I have this roll part on my screen. So the tools we're looking at here are flat solid, flat pattern, and export flat pattern. So if I go to flat solid, notice I'm just going to say a stationary face, which will be upward and a flat. So by selecting that face, you see I have now a flat solid, and see how flat solid is listed over here in my part navigator. It is a separate body. I can hide that separate body. I could hide the formed body, show the flattened body. It is a solid body that exists there. Okay. Let me go ahead and show my formed body back. Now, if I want to create a flat pattern, to go to DXF or to be placed on a drawing, I'm going to use the flat pattern command. Same type of options. I'm just going to grab the same face, and it's going to flatten it. And notice what it's doing for me. It's going to take that flat pattern and create a separate model view called Flat Pattern 1. So notice the form model, we don't see the flat pattern anywhere. Now underneath model views, if I double click on Flat Pattern 1, you see there's my flat pattern. And then there's the callouts we'll talk about. And we're going to talk about those a little bit more in just a second. Let's look at our other example. Here, if I create a flat solid, you'll notice earlier I just selected the face, but I can also define an orientation and have it move to absolute, my absolute coordinate system. So what that looks like, I'm going to grab a face to be upward and a flat, and then grab an edge for an orientation. See how it applies that blue arrow? So I think of that as an X direction. Right? Once again, it's a flat solid. So if I hide the form model, you see that it's a separate body. This would also be, maybe in my assembly, I need to have a flat solid, in my assembly to show maybe part of a progressive die. That would be a way that I could create that flat solid and then take that into another file. To continue on, let's go ahead and create a flat pattern in this model. Just like we did with the flat solid, I can have it move to absolute coordinate system. I'm going to grab a face to be upward and a flat, and an edge for X direction. Once again, it's going to create that model view as we saw before, and there's my flat pattern. So you see by default, or basically what's on my preferences, if I go back to preferences in NX sheet metal and look at my flat pattern display, see how it's showing bend tangencies in the color? If I turn off the bend tangencies, see how those do not display in my flat pattern anymore. Or if I turn on down the bend center lines, which you'll see left here, and I turn back on bend tangencies and hit apply, you see how it switches. So basically what we're showing here is how the flat pattern is going to be displayed. And then the information that we're seeing from the callouts is calling out bend radius, bend angle, bend direction, and so forth. So if I hit OK, you see that those callouts are automatically derived: bend radius, bend angle, and bend direction. And the bend direction is based on my flat pattern direction, right? Whether it has to fold those up or down based on my stationary face. Let's go ahead. I'm going to keep this where it's at right now. And let's just create one more example just to get something a little more complex maybe than what we were working with here. I'm going to create another tab as we did earlier. And maybe we're building some kind of electronics cover. I'm just going to quickly grab T on my keyboard to do a quick trim to cut that away. And I'm going to use my auto dimensions to drive that shape. Maybe I want this to be 4x6, and just drive these quickly to keep it on centered. And maybe we want that length to be 2 inches. And instead of that angle dimension, I'm just going to drive this over here to fully constrain the sketch. So here we're pulling, this was a new file, so I didn't change it to 50 thousandths. Notice how it's pulling out whatever default material thickness I had. In this case, I want to come in and build a contour flange as a secondary feature. We built a contour flange earlier as a primary feature to create that rolled part. Here I'm applying it to the edge of this existing tab, so it's going to be a secondary feature. So I'm just going to build a profile off of that. Once again, quickly just use my auto dimensions to drive the size and shape of this profile. Make this 2.5 inches long, and then we'll make the foot down here at the bottom as a 1/2 inch. So see, it's going to take that profile. I could do a linear kind of extrude, or maybe I want to wrap it all the way around this. Like I said, I'm building some kind of enclosure. So notice how it mitered those corners. You know, we can come in and make that watertight, maybe weld them, etc. But now if I look at the flat pattern of this guy, so once again, it placed it in the model view. You see we have something a little more complex. Right? Notice the shape of the flat pattern, how it treats everything, even in that contour flange, as a bend. I have all the information pulled out from my callouts, bend radius, bend direction, you know, just in a matter of setting up my parameters in basically 2 clicks. So I just want to show you something a little more complexity there. The final piece of that, if I switch back to the previous part, was exporting the flat pattern to DXF. So first of all, you notice how the flat pattern view is my work view. To go back to the form, I just click on one of my, or double click I should say, on one of my trimetric or isometric views to get back to the form model. So it's very easy to switch back and forth. Underneath this flyout, you'll see that there's a newer tool called Export Flat Pattern. And what this is going to do is just grab an existing flat pattern. I just grabbed it out of my part navigator. And then here I have options, what do I want that to go to inside of DXF? Notice DXF here. Do I want the bend up center lines, the bend down center lines? Notice here I have the tangent lines turned off, unlike I did here in the default flat patterns I was creating earlier. And I'm just going to say go ahead and grab OK. And what it's doing is it's creating or taking that flat pattern and it's going to spit it out to DXF. So what this is a way of, I don't have to necessarily throw this on a drawing and do a file save as DXF from the drawing. The next thing we want to look at is creating the flat pattern on the drawing. Okay, so just so I'm not switching back between the slides, I'm going to show you how to throw that on the drawing, but also let's talk about how that flat pattern is calculated. So here you see I have a similar shape, and then down the bottom you see the web length, the 2 inches, you see the bend allowance, the 0.104, the original tab, which was 6 inches wide, and the bend allowance on the other side, once again 0.104, and then the 2-inch web, for a total flat pattern length of 10.209. So here's the formula we're looking at. Bend allowance is calculated by bend angle, and we got to convert that to radians. I worked through some of this presentation a few years ago, and I had to dig deep to remember radians conversions. So it was pretty funny thinking, okay, pi over 180, 90 degrees, all that stuff. That was pretty interesting. So I can multiply that times the bend radius plus the neutral factor, which is that K value, times the thickness. So in my example, I had a bend radius of 50 thousandths, a neutral factor of 0.33. The neutral factor is going to be based on your sheet metal knowledge, your shop, your tooling, etc. And then the thickness, once again, was 50 thousandths. So you see that that's giving me the bend allowance of 0.104. And then by the time I take the 2 bend allowances plus the 2 flange lengths, if you will, the web lengths, plus 6 inches for the tab, that gives me a total of 10.209. So there you see the math. So there was the flat, flat, and flat. So the 2, the 6, and the 2, plus 2 times the bend allowance. All right, so how do I place this on the drawing? So once again, I have my flat pattern as a model view. So whether I do a master model concept, I start a new draft, or if I keep it here stored in the same PRT file, I'm just going to do start drafting, grab my template, my sheet size, and here inside of my base view command, you'll see I have my model views, right? So maybe I wanted to add a formed isometric view, which you're probably used to doing. But now notice, because it automatically puts it in a model view, you see that in my drop-down list I have flat pattern 1 displayed. So as I grab that, it's grabbing that model view and placing it on the drawing, and see how it's bringing the callouts along for the ride. Let me run in here my drafting preferences and turn off my borders here for a second. So you see that call out information, the flat pattern, everything comes along for the ride with the model view, so it's very easy to place it on the drawing. So maybe for manufacturing information, I can go ahead and place a couple of overall dimensions for that flat pattern so that it can get manufactured. One other thing I should have shown you, I spit out the DXF. So let me show you what the DXF looks like. I'll just bring it back into NX to show you. So let me browse to my DXF files on the file open. And let's go ahead and grab that. So I'm just going to bring it in inches, and I'm going to place it on a drawing sheet. There I get a nice little preview of the DXF. This was a different one I'd saved. I grabbed the wrong one. So there's my DXF. This little dotted line back here is actually my my model space, or my sheet size, I guess you'd say. If I go to Format, Layer Settings, notice the layer structure I get. So here I have a layer called 2. If I hide that, see, that's my bin center lines. If I hide 6, see, that's my outside shape of my profile. If I grab the right DXF file and it had that slot in there, I'd have another layer set that would be internal cutouts. Notice how, once again, in my options, I did not have tangent lines turned on. So I just wanted to bring that up and show you the DXF file that it created. All right, so we looked at the flat pattern calculations. I'm going to run over just a few minutes. I apologize. Sometimes I talk a little more than I plan on. But just to show you a quick example of the lofted transition, see how we're going to more of a rectangular shape to a circular shape. So let me go ahead and grab a file over here that I have a couple of sketches already created to save a little bit of time here. And back in sheet metal, I'm going to construct this using the lofted flange. So I'm going to go from one section to another section and loft that up. Here I have options to use multi-segment bins. So that's kind of the triangulation for bins, you know, as you kind of equally space those out, which will also give you index links for your DXF and the flat pattern, or your flat pattern in general, I should say. All right, so I'm going to go ahead and finish off that particular lofted flange. Let's clean up the sketches in my datum plane. So now to create the flat pattern of that, I'm just going to grab a face to be upward and a flat. Hit OK. Once again, it's going to create that model view. And you see here is my particular flat pattern, right? Notice it's a variable bin radius as it transitions from one cross section to the other. So like I said, not going to spend a lot of time there. I just wanted to show you the different options there, and really maybe even how to create a lofted flange or a transition like that. I got one more topic to talk about, so bear with me a couple minutes. Here, at this point, we've been looking at shapes that are created on, you know, a brake, right? A press brake. We're creating flanges off of tabs, you know, bending sheet metal. What if we have a complex shape? You know, sometimes I get the question, how do I flatten this crazy shape? So there is a tool out there called Step Formability. It is part of a progressive die package, but it is also an add-on tool for those of you that need to be able to flatten these complex shapes, like you do a large piece of this of your business, but maybe you don't need the entire progressive die module. Also inside of this tool, not only can we get a flat pattern, which you see on the lower right, we also have some analysis and reporting tools included. So just quickly here, run through an example. Here I have a part, and what we want to do whenever we run this one-step formability tool, we want to look at a surface. So the first step of that would be to come in and create a surface, in this case a mid surface, maybe halfway through the material thickness, and you see that we've already created that. So I have my offset mid surface halfway through the material thickness. So I'm going to hide my design body and only look at that sheet body or that surface for the one-step formability tool. So if I go to Analysis, Analyze Formability, one step, I'm going to come through here and I'm just going to grab my surface. And what I need to tell the software to do is, how do I need to hold it? What pieces of this geometry cannot move? So I'm just going to hold these edges so it calculates the flat pattern based on holding those edges. Just like any FEA modeler, meaning finite element analysis modeler, we're going to have material properties, we're going to have constraints and loads, right, to determine that. So you can kind of think of this as an analysis tool. Here I have a material library, and inside that material library we're going to pull Poisson's ratio and modulus. Here I need to tell the system which direction I need to form that. So I'm going to grab this direction you see highlighted here inside of that orange kind of gold color. Excuse me. And what we're going to do, because this is an analysis tool, based on those parameters, we're going to go out and create a mesh. So if you guys have done any FEA or finite element modeling, you know that you're going to create, maybe it's a solid mesh, or in this case, we're going to create a surface mesh about that part. So it's going to take those little triangles of the mesh, and it's going to determine how to flatten those by holding those in boundary conditions, right? With that, we're going to go ahead and say, I want to go ahead and run the calculation. So what we're going to do here is, once again, it's looking at material properties, the calculation, and notice in blue it's going to give me what that flat pattern looks like. If I rotate this up so they overlap, you see that the edges highlighted in orange is where I held the model, and then you see everything else formed accordingly based on my mesh. Not only do we get the flat pattern, I could take that profile, and if I rotate it over, you see that it is a flat profile. I can take that profile, throw it on a layer, put it on a drawing, send it out to DXF, whatever it may be. But also I get some analysis tools. So I can display thickness, what areas of the model am I going to have to worry about thinning happening on the model. You notice here, that's where that deep draw, where that deep pocket is. So I'd have to really take a look, and what this is going to do is also help me kind of, look for or predict a tear condition. Also, I can look at stress, where max stress is on that part, like you'd expect, probably the same type of location. I can look at strain on the part. Once again, I can look at that flat, see the mesh flat in there. There's my profile. And the final thing it'll give me is a report. I don't know if you guys have done analysis before, but maybe I need to create a report for my customer by taking screenshots and entering this data. You see that this report will do so for me. There's my material properties. There, we're holding each of those edges. It's talking about the mesh, how many nodes and elements we have for that particular mesh. And there's a screenshot of the thinning that we looked at. There's a screenshot of the strain that we looked at. And then there's the flattened shape. So I had stress turned off for this particular report. But notice just by clicking one button, I have that report, that I can share with my customer. Why would this tear? I'm kind of worried about that deep pocket, etc. So I know I probably rushed through the example of one-step formability very quickly there, but I am running out of time, so I apologize. So once again, I know that this is kind of an add-on tool, but for those of you that do shapes like this and flatten shapes like this all the time, this is definitely something you probably want to take a look at. To wrap up here, once again, replays of our lunch bites can be seen at allyplm.com. And here's my contact information. If you do have any questions regarding today's session, please shoot me an email and we will investigate that. We have an Essentials for NX Designers class that we have here at Ally PLM here in Cincinnati, Ohio. in our training facility. Those are the upcoming dates. We do cover sheet metal on Friday, day 5, and there's more information on our website. Just to wrap up, once again, if you have any questions, please let us know. I appreciate your attention this afternoon. Hope you found this session informative, at least where to look for some of those tools and where to find some of your preferences in the unbend, rebend tool, your flat patterns, etc. Also, email us any questions you might have for our tech support team. We're here to help. And once again, I appreciate your time, and thanks, and have a great afternoon.